Welcome, everybody. Today's session is called Hosting a Massively Scalable Website Around the World for a Fraction of the Cost in a DevOps Model. So we're actually going to be talking about how this relates to serverless architectures. Who here is interested in serverless? Who here has a good foundation of serverless? Okay. So just to reiterate, this is a level 1 session and not really a deep dive, so we are going to try to keep it somewhat general and just discuss the background of serverless, a little bit of details of how AWS instantiates serverless and what we could do with serverless by these scalable architectures. So what can you expect from this session? Well, we're going to talk about serverless. Well, what does this mean? We're going to review the cloud computing evolution that brought us to this new paradigm. We're also going to look at how this compares to traditional computing approaches. We're going to talk a little bit about serverless design and scalability principles. We're going to identify AWS services that support this model. We're going to review some simple and complex architectural patterns along with some diagrams and examples. We're also going to look at how serverless takes advantage of scalability and some development approaches to serverless architectures, both structured and unstructured. We're going to talk about cost effectiveness, how we can compare load and costs on a traditional site versus a serverless site, how we can compare and look at the total cost of ownership for these workloads, a sample pricing example, and then also some real-world use cases. My name is Paul Andruski. I'm a senior cloud architect with Cloud Nexa.
My name's MJ DiBerdino. I'm the CTO and one of the founding members of Cloud Nexa. And real quick, just a brief history of who Cloud Nexa is. We've been a partner of AWS since 2008. We're currently a premier partner and a managed service provider. We have, as a total of certs, 50 plus within our company. We also have what's called a Cloud Warrior. So we have a program within Cloud Nexa where if you earn all 5 of your certifications, you're classified as a Cloud Warrior. We have 6 of those members, Paul and I included.
You good?
Yep.
Okay, so let's talk a little bit about going serverless and what this means. But before we do that, we should take a little bit of a look at the history or the evolution of cloud computing. So there's many historical perspectives that we can take, but one way that we can look at this is through the perspective of increasing abstraction. So originally servers were hosted on-premise in closets. These were eventually moved over into data centers. And once we moved into data centers, virtualization was a huge enabling technology for this. The hardware was the unit of scale, and our physical hosting environment was abstracted away. The next major shift came with infrastructure as a service, or IaaS. The physical hardware became abstracted away, and our operating system now became our unit of scale. In AWS, this is sometimes referred to as infrastructure services. Some easy examples to list would be the Elastic Compute Cloud, EBS, VPC. The next iteration we can look at is platform as a service. With platform as a service, the operating system is abstracted away, and the application alone becomes the unit of scale. In AWS, this is sometimes referred to as container services, not to be confused with Docker or the EC2 container service. Examples of this would be the relational database service or EMR. And last but not least, we come to serverless computing, sometimes identified by the acronyms FaaS or function as a service, BaaS, backend as a service, or mobile backend as a service. With serverless, AWS sometimes identifies this as abstracted services, but essentially the language runtime is abstracted, and we are just presented with the function as our unit of scale. Some examples with AWS would be Lambda, API Gateway, and Cognito. So let's look at some characteristics of a sample server-based architecture in AWS running in our infrastructure as a service mode. We can focus on a multi-tier architecture, particularly a sample 3-tier setup. A multi-tier architecture is a cornerstone architecture pattern with guidelines for ensuring decoupled and scalable application components. We segregate web, application, and database tiers, but for this presentation, we're going to refer to them as the presentation layer, the logic layer, and the data layer. In a multi-tier application, the network acts as the boundary between all of the tiers. The code is not really that innovative. In fact, you might say that it's a direct result of the actual pattern, maybe even driven by the n-tier pattern. So let's break down the tiers for this example. For the presentation layer, we can instantiate this using EC2 instances that act as web servers. For the logic layer, we can use, again, EC2 instances that act as application servers performing some kind of logic processing. For the data tier, we can use EC2 instances or relational database server instances. Some other notable characteristics to consider is that we have to manage server resources. We have to manage and configure the operating system, VBS volumes and storage, the types of instances that we choose, the cost associated with all of that. We have to also manage the supporting software that runs on these servers. This can also include licensing costs. This can also include any additional integration points that we own. So capacity and performance planning becomes an issue as we're responsible for scalability. We're responsible for all levels of forecasting. And ultimately, the costs for all this. Aligning costs with utilization can be a very difficult endeavor if done manually. When we compare this with the characteristics of a sample serverless architecture, we can see the following. For our presentation tier, we can use S3 and CloudFront. We can have static website content that's hosted in Amazon S3 and distributed using CloudFront. This is a cost-effective alternative to hosting content on a server-based architecture. For a logic tier, we can integrate Amazon API Gateway and AWS Lambda, which is a fully managed service for creating and managing APIs. This API Gateway can be used with Lambda, which is a fully managed service for arbitrary code functions, our function as a service. For the data tier, we can use various data storage services. We can leverage Elasticache. We can leverage DynamoDB. We can leverage even S3 if needed. What does this mean to us? Well, it means zero management of server resources and supporting software. The operating system has been eliminated. We don't have to focus on aspects like architecting for high availability. We don't have to look at server operating system management. We don't really have to worry too much about capacity planning or scaling. All of this is now fundamentally being taken care of for us by AWS. So that's just a general overview of where we're headed with serverless. Are there any questions on that topic? Do you have any questions?
No, I run this every day. So. There's no,
Okay.
I just want to make sure, I mean, from a baseline perspective, because we're going to start getting into some designs, and I'm not sure if oh, there is a question way over there. Content management system like WordPress, for example? Sure, or Drupal. So what Paul was describing was a server-based architecture as it compares to a static. So WordPress falls right into traditional server-based. When you look at static, it's not a straight CMS like WordPress is designed where you can log in as an admin. You would use more of a framework such as Middleman, which we'll show at the end for use cases, and more locally design and push out through, if you have a CI tool or CD tool, into S3 and deliver it through CloudFront. So it's slightly different. It's not going to have the same type of admin functions. But again, when you compare the two, and we'll get into this a little later about cost, it's extremely different. Yeah, okay.
Okay, so let's look at some design and scalability principles for serverless architectures. First, we should identify some supporting AWS services, or rather define what they are. Now, AWS provides us with a few key supporting services for building serverless architectures. Obviously, the main one is AWS Lambda. This lets us run code without provisioning or managing servers. This is our function as a service component. Amazon API Gateway is a fully managed service that makes it easy for developers to create, publish, maintain, monitor, and secure APIs at any scale. Cognito lets us easily add user sign-up and authentication to mobile and web apps. Amazon S3 is obviously the simple storage service. CloudFront is our CDN, our content delivery network. And DynamoDB provides us with a fully managed NoSQL database service. Let's observe some simple architectural patterns, and we're going to break these down in the next section. So persistent data, what do we mean by this? Well, this could be something as simple as saving a quote with some kind of static data in S3. For web form submissions, we can submit web form data and with some kind of processing event being triggered on the back end to fulfill some other function. For authentication, we can offload authentication to a serverless backend and plug this into any of the architectures as needed. Oh, so we missed that. So a couple of architectural advanced patterns. We can look at fully hosted S3 websites. We can look at Internet of Things or mobile backends. And we can look at microservices architectures. Microservices architectures obviously are not three-tier, but we can easily bundle together API Gateway and Lambda to create a microservice. So the components that we talked about, S3, CloudFront, API Gateway, Lambda, even DynamoDB, all of these scale automatically. We don't really have to worry about under-provisioning. We don't have to worry about over-provisioning. And we pay only for what you use. We pay for what we use. So let's take a quick comparison of considerations for a server-based versus a serverless workload. This is not an apples-to-apples comparison. Obviously, WordPress is a proprietary product, and we're just looking at this from a high-level concept in terms of what we would be responsible for versus what we would not be responsible for. So for a server-based workload like WordPress, we do have higher investment costs for baseline resources. We do have to worry about requirements and capacity planning for all of our deployment tiers. We do have a higher overhead for infrastructure investment, and we have ongoing infrastructure management and maintenance. Comparing this with serverless we have a minimal baseline investment, we have minimum requirements planning, and no capacity planning is needed. The model is really pay per request or pay for what you use, and the infrastructure is abstracted away, managed, maintained by AWS. So if we look at this diagram, this is essentially our WordPress architecture, or a sample WordPress architecture. We have a VPC that's highly available with multiple availability zones. Our data tier consists of an RDS database configured in multi-AZ mode. Our logic tier consists of an auto-scaled set of EC2 instances running into availability zones with an ELB proxying traffic. And our presentation tier consists of end users' browsers using Route 53 for DNS, CloudFront as a CDN, S3 for static assets, and the Elastic Load Balancer to proxy requests to server resources. We mentioned the simple architectural pattern before of persistent data. This is an example of how it could be instantiated. So in this diagram, a quote is being generated and persisted for an extended period of time. Our presentation tier consists of client browsers using Amazon Route 53 for DNS and CloudFront as a CDN for the blank quote hosted in S3. Our logic tier consists of an API gateway which proxies the populated quote to a private S3 bucket, saving the quote. And our data tier consists of S3 where the quotes are being saved or stored. We can expand this example and think about web form submission. Now in this diagram, a web form is being accessed, filled out, and submitted by an end user. Our presentation tier again consists of client browsers using Amazon Route 53 for DNS, CloudFront as a CDN, and for a quote that's being stored in S3. Our logic tier consists of API Gateway, which receives data from the submitted form and invokes Lambda. Now, API Gateway essentially acts as the bridge that connects our presentation tier and the functions that we write in Lambda. Lambda then transforms and moves data to DynamoDB for future search and retrieval, and Amazon SES to send a verification email to the end user. Our data tier in this example just consists of S3, where the blank form is being hosted, and also DynamoDB for search and retrieval once the form is actually submitted. Our architectural pattern for authentication is essentially the same as the previous diagram we just looked at, with the exception of Auth0. The inclusion of Auth0, we basically have integrated an authentication service that supports JavaScript client-side authentication as designed for mobile devices. Now, how do we work with or deploy two serverless architectures? We can really look at two potential models. An unstructured model, the simple model, is just using serverless framework. Serverless framework, this is an open source application framework to easily build serverless architectures on Lambda and other clouds. We can easily build a Lambda function and publish it to AWS. If we're going to talk about enterprises and doing a more structured approach, we have to look at a more advanced build workflow. This is something along the lines of continuous integration and continuous development. So for this type of model, we have to be concerned with our code repository, which can easily be GitHub, or typically is GitHub. We can look at our build platform, CodeShip in this case, which pulls from our code repository, a quality review control system like CodeClimate, and eventually publishing this to AWS in a controlled way and repeatable way.
So let's pause there for a second. And we presented 3 different use cases. And again, this is supposed to be a learning, hopefully an interactive session. So please share any comments or questions that you have, or I can share maybe some actual use case up back there. Yeah.
You mentioned serverless as a framework. Are there any other frameworks that allow you to work with Lambdas?
Did you hear the question?
Serverless is the most common one we use. So maybe there is, but that's probably the one that's going to gain the most traction in the near future. Next.
Go in the corner.
Yep.
With regard to scalability on API gateway and Lambda functions, do those products suffer from any sort of like quick bursting issues, or do you not have to worry about that at all? Like with ELB, you got to worry that like if you for some reason got a ridiculous amount of traffic, it might take a while for ELB to scale up. Do you know if those?
Yeah, you're referring to like pre-warming the ELBs, or basically putting in a ticket with AWS to get them ready for massive spikes.
Do you have to worry about that at all with API gateway and Lambda functions?
To date, I haven't really come across that yet, but it's still not that ubiquitous of a service.
Yeah, I mean, what we would always recommend is you still want to go through and ensure that your code quality is where it needs to be. So if you're running a Lambda function and it's timing out, then there's probably something wrong before you even get to Lambda. But it's not necessarily the case. I mean, you still want to go. I would never say never worry. It's just you're still developing your app. You're still relying on a third-party service. So you want to ensure that the quality of your product that you're putting out there is where it needs to be. Yeah.
That the first time the container gets built, it gets built one time and then it caches it, right? So the first time you call that request, it will take a little longer, right?
Yeah, the first time before it gets cached, once it's in there, then it basically becomes what is repeatable.
Yeah. I mean, and then you can worry about your expirations, but we're still talking milliseconds, right? Yeah. Yeah. Go ahead.
Does the Lambda SDK integrate with any identity providers so you can actually track like what session is being processed at the moment?
With Lambda, we can talk after, and I'm not sure off the top of my head. I mean, we do integrate. So Cloud Nexa deployed, we have a product called VNAC, and it's completely serverless on the front end. We have integrated with items like Intercom, where we're tracking clicks, but I'm not sure if we extended that to Lambda. I have to double check, but we can take that after the session.
So I came in this conference for this session particularly about the cost saving side of it.
Yeah.
Have you guys actually done comparative analysis between having everything serverless, using all the Lambda services and all that, versus a more traditional setup with containers and spot instances?
So I'm going to cover cost-effective in this section here. I can talk about Spot. I didn't have it specifically on here, but I can definitely talk about Spot. Just do a follow-up question right after the cost portion.
The question is, of course, for example, WordPress is a complex piece of software. So what I would like to understand, because if I understood correctly, in the diagram that you shown, that there is the Lambda that is basically doing something that is similar to what WordPress can do. I would like to understand how much complex a Lambda can do, or if in order to, let's say, create something that is covering all the functions that is needed, I will be need to create many Lambda functions doing many different things.
So just to be clear, we weren't saying serverless to replace WordPress. We were just strictly giving WordPress as an example of a traditional server-based technology because most people understand that. So it wasn't about it being serverless replacing it. So we didn't build a serverless content management system, although there are offerings out there. There are SaaS products out there that can do that. But that's not where we were going with it. We just wanted to give a baseline of how to compare the two architectures.
So then it's not necessarily possible to replace everything with serverless today.
Well, everything is so broad. No, I wouldn't say you're going to replace your massive ERP. But from a very baseline, I absolutely think you can replace your company website. So we did it, right? So we were running on WordPress, and we replaced it with serverless, and everything that Paul went over was actually our architecture. So he mentioned quotes. So one thing that we do from a persistent data perspective is we allow people to do a live quote on our site, and if you went to vnac.io, you would see it, and you pick and choose all your configuration that you need. It spits out a quote, then you can save that. And that was the persistent data architecture. And then what we do is we can recall it later on when you actually want to launch.
I have a question over here. Sorry,
Good.
I can't see you for the stereo. There you go.
Yep.
Basically, along the lines of that question in WordPress, how do you get around having to hand code every individual page? Are you still using a data? WordPress, right?
Yeah. Yeah, I mean,
AngularJS. I can answer that.
yeah, go ahead.
Okay, AngularJS.
Yeah, I mean, we use AngularJS as the front end, which is a single page front end, right? So we're not having to redupe every single page. We're just providing the content, but the theme, the overall template is still being carried out. So we're not individually creating each page. It's not like an old school HTML. So it's a little different.
How do you determine how many Lambda functions you need to spin up for a given load, or what determines it?
In terms of what, so you're asking a question about how do you determine how many Lambda functions? Well,
So you have a
give it a
given
look.
load, right? Something needs to be done, which takes more than 5 seconds or something like that. Or what are the,
So I'm not.
I mean,
I'm sorry, I don't
how do you
understand the
scale?
exact way.
How do
You just get, well, you're decoupling your functions down to the least common denominator as often as you can. But it's tough to just generally talk about without a specific use case, so I'll just use one use case within our product that makes it simple. So what we did is we process CloudTrail logs, and we break down each JSON file into its own function. So we're running that across, we manage over 1,000 accounts, so it's hundreds of millions of records a month, but it's only a few Lambda functions. So we're one ingestion, one parsing, and then one export. Yes.
How did you handle the concurrent execution limits Lambda functions with regard to scale?
Can you give a specific, I mean, so we bumped into, obviously there's a lot of trial and error. We bumped into a lot of limitations we were timing out, right, in the beginning when we first started with it. It really came down to how can we efficiently parse data within the given time frame. So we started realizing that if we were trying to do too many customers at once within one function, it would time out immediately. So we looked at it again from the least common denominator as small of a process as we can, and we proceed. But it's trial and error. I mean, there's not a magic wand that we were able to wave. So I see a time check. Okay. So this isn't necessarily about Lambda. I think every question has been about Lambda. This was more of an intro about how to proceed with serverless technology and basic examples of how to go. I know we've had a lot of Lambda questions, but
About your experiences in your development, just because we're trying to get to that, right? Just the lambda between asynchronous and synchronous node. How do you utilize it?
let's take that after the session. We can discuss that. Okay. Yeah.
I know that this question is going to be related to Lambda and ACI gateway, but I think it's
Hey, you can say one. Thank you.
linked to this serverless architecture as well. So does API gateway and Lambda supports WebSocket connections? If not, then what is the alternative?
I'd say it's something we should take offline after the session.
Yeah. Okay.
It's too specific.
Yeah, it's very specific. We're trying to keep, this is a beginner level class. Again, we don't know everybody that's in the audience. So, yeah, go ahead.
Framework questions. So in terms of like you were just saying earlier, like you were doing trial and error, but coming from a traditional setup going into serverless, what kind of high level debugging tools or tips that you guys do differently?
So we run through code climate for our quality and scoring. And in terms of debugging, we leverage on the Chrome browser the console to see errors. I mean, we're not in, if you were successfully able to deploy, let's just take a basic website, and to be honest, there wasn't a whole lot of debugging we had to do from a front-end website. It all is just back-end process, and I'm not really sure, to tell you the truth. Let's go on to cost examples. So we were talking earlier about WordPress versus serverless and how the costs differ. So from what Paul was describing, in a traditional sense, you're going to have EC2 RDS. The request, if you take let's say an M4 large, you're going to be able to get approximately 1,000 requests. If you need higher, then we can look at doing auto scaling. We can look at doing additional load testing or going up to higher servers with higher capacity. But as you do that, the costs just start increasing greatly. If we ran an EC2 instance and we did a load test and it maxed out at 100, and we're running WordPress, we're going to start analyzing every single plugin. We're going to analyze every path that's come in, every JavaScript that's being ran. And ultimately, a lot of times, generally people will just throw more hardware at it, hoping it solves the problem. So, if you start out at a couple $100 a month, you can easily start getting into the $3,000, $4,000, or $1,000 range. Then you want to, if you want to take that and then start looking at how to save costs within a server base, then you can do some RI planning. However, that's not always the simplest thing because you don't necessarily know the scale that you're going to need within a few months. And you could overestimate or underestimate. But in serverless, like Paul mentioned, it's per request. So when you look at your front-end distribution of CloudFront, by default, the hard limit is set at 100,000 requests per second. This is extremely different when you're planning for scalability on the CloudFront delivery side than on the EC2 side. And if you need to increase that limit, it's a simple request to AWS support. And the hard limit of data transfer is 40 gigabytes per distribution. So when you just think of the sheer mass of scalability, on the serverless side, it's really off the charts. And then when you consider total cost of ownership into bringing in traditional servers, you have to think about not only maintaining it, but all the vulnerability that could occur, patching, additional development, and then you have to consider each price point along the way. So if you want to add, more database, read replicas, if you want to add in a auto-scaling environment, if you need to add additional EC2 instances, you just have to think about this continually. But with serverless, and you think about cost of ownership, outside of development, because you're always going to have development, it's AWS maintained. The cost of ownership greatly decreases. It's huge cost savings just from an operational standpoint. And here's a real price example that we gave. So just think bare minimum, not even getting into auto scaling or any of the fancy stuff that you can do on the traditional side, on the server side. If you use a basic LAMP stack, running an M3 medium, a single AZ RDS, 100 gigs of storage, 50 gigs of data transfer, it's approximately $1,600 a year. But you don't have any high availability, and you see no redundancy, and then you're constantly going back to that cost of ownership. You have to think about server uptime. You have to think about any security vulnerabilities. So this $1,600, that's just the AWS side. That's not your operational cost. That could be, you could have service contracts for a couple $1,000s a month to maintain that. On the serverless side, just very, very basic, running your company website, have 1 gig of storage on S3 and 50 gigs of transfer a month, it's less than $200. Cost of ownership went down, operational costs go down, your fixed costs go down, but then you inherently receive that fully redundant across many geolocations around the world, and you're ensuring that you're falling within a best practice. So before I go to that, there was a question over there about price. So you had a question about price. I just want to bring it up again.
Right. So the question was about whether if you put spot instances
Yeah.
into consideration,
So the spot market is great. We leverage the spot market as well. However, when you think about running, and we're just sticking with the theme of WordPress throughout here, if you think about running WordPress, if you become outbid, that site goes down. So what can you do? You can go a little more advanced, look at ECS. You can run 2 auto-scaling groups, one that leverages spot instances and one that leverages on-demand instances. So that way, if you do get outbid and you lose your spot auto-scaling group, you have a backup always running. But now you still need that baseline of on-demand. I would be worried if it was me that I would get outbid, and if I want to always keep on top of it, your prices can go from 5 cents an hour to $1, easily $2 sometimes. We watch the spot market very closely. During certain times of the month, we've seen prices jump from 7 cents to $1 an hour. So you're going to save, 80%, 70% of your spend for 3/4 of the month. But if it jumps up and you don't want to lose your content, then you have to pay. Or like I mentioned before, you can do something a little more advanced and have ECS, Elastic Container Service, manage 2 auto-scaling groups going on. But that could be very complex. Yeah.
Does AWS come with a built-in solution to detect if the 100,000 requests per second or the 40 gigabytes has been exceeded, so to know that we need to request a limit increase or whatever?
Yeah, you're going to recognize it immediately because you're going to start seeing bad requests. but I believe you can monitor it in CloudWatch. I don't know offhand, but I believe you monitor that in CloudWatch. But I'm not sure what type of user load you're getting, but if it's
Yeah, like
good.
you say the TCP said doesn't even make it because that 40 gigabytes that's probably
And it's per,
right?
yeah, it's per second. So it's the 100,000 per second requests. So it's not 100,000 for the month. It's 100. It's not like credits that you're earning. It's a per second request. Yeah.
So CloudWatch probably has something like that.
Yeah, I would think so, but again, I don't know off the top of my head.
You guys mentioned the company website, serverless architecture. Are you going to go over anything else you've made in serverless setup, or anything
Well,
more complex than that?
Well, no. Again, this was for beginners, so we're not going to cover that now. But we have built a cloud management platform as well, which is much more advanced. It involves audits, cost reports, server management. But when we went over this during the thing, it was beginner level.
Let's talk about Lambda some more, right?
Well, like I said, we. And where do you go from here? Just wanted to show 3 examples in case you guys aren't aware of some frameworks that are out there and that exist, or different use cases that people are leveraging. So I'll just mention real quick. So blogs, again, WordPress very commonly used for this, but there's a product out there called Jekyll. It's a fantastic framework. It's a blog generator, very simple to use, and you can post as the numbers here represent stars, favorites, forks, bugs. Jekyll is one of the most popular serverless frameworks to use out there. We have a knowledge base, another common use case. Cloud Nexa, as a managed service company, we have many of the same questions. So we built a public knowledge base, completely hosted with or through MK Docs. It's hosted on S3 and CloudFront, but we built it with MK Docs. And the last one is a website generator. We happen to use Middleman. Again, we're using AngularJS as the front end, but these are just 3 basic examples that you guys can think of where to go and things to explore and hopefully make the leap over. And these are all free to use too, which is great. And that's it, unless there's additional questions.
I have a question. What's the difference between Jekyll? I know Jekyll is a static site, right? It takes a template and gives out a doc for each page. What's the difference between middleman? How does the middleman?
So, what I'm using here as an example is Jekyll as a blog generator. So it's about continually refreshing more dynamic content is how I reference it as. And Middleman is more of like your static site. You're not making adjustments to it often. It doesn't necessarily have the same type of tool set behind the scenes, so you can just write your posts and then post them. Any opinions?
We would just say, start small, identify your requirements, see what's available to you, what's not, where the gaps are. And again, it's still a pretty new frontier. Even for us, some of the examples that we showed are pretty simple. They're not very complex. It is a work in progress. So our real advice would just be to start small and look forward, as opposed to giving you a real blueprint that you can follow. It is still very highly give and take, back and forth kind of.
Do you have any examples that you're thinking of?
Yeah, we've just got a portion of our app which is agents call in,
Probably not, but it's hard. I mean, that's a very generic description. It sounds like a good candidate. We can chat a little more about exactly what it does. Okay. Thank you.